So if you cannot hear me, tell me. I will just use the microphone. Otherwise, I will speak it in this level. So computer network. Last week, I think assignment 0, I upload to the Hanyangin. So you can take a look. I asked for some of the network usage in your mobile phones and etc. So far, I didn't hear any complaints about your privacy issues, so I'm assuming that's okay. I also forgot to mention those of you exchange. I mean, it might be difficult you might not be using the network here, so it's okay for those of exchange. If you can submit it, it would be nice. Otherwise, it's okay. But the Korean students, I hope that you can share your data statistics with me for the course. Okay. So chapter 1, the part, obviously I also mentioned top-down approaches. We'll be discussing from the top layer, which is before we're discussing on the top layer, application layer, which is we're going to discuss in general description of the internet, the network, and some of the terminologies that we might need to know before we get into the actual technical details. So it will be most likely the overview of the internet itself, networks in general, some of the terminologies that you probably heard before, you're already using it here and somewhere else. So more like an overview. Hope we can, this week and next week will be more like overview, and then we will go into the application layers and etc. Our goal is to get a feeling of the terminology, get used to it. More depths, details later. Every chapter will be covering a single layer. So hope to get to that soon. Internet is a large and more clear example of the network itself. So we're going to discuss a little bit on the internet part and blah, blah, blah. What is the internet, protocols, edges, host, access network, physical media. What is the internet? I don't know. There is a single definition of the internet, but everyone using it every single day. So you guys know what feelings like, probably, but you never consider how it is a architect. I mean, how is it composed of a different network? We're going to discuss that a little bit. Network cores, packets, circuit switching, internet structure. Is the current internet similar to the old telephone network, circuit switching network, or is it different from that? What is better or what is suitable for which situations? And when we're discussing in the network, most of the times we try to get the good network connections. How do you describe a good network? The quality. How do you measure those type of stuff? It's typical performance metrics that we'll be looking at is losses, delays, and throughput. In more simpler term, bandwidth, I guess. You guys, when you're watching a YouTube clips from your over the LTE or LTE advanced network, you're not very happy if you don't get a good connection, right? So. However, there are more factors to look into if we wanted to describe the performance of the network and protocol layers and etc. History is not that important, but we will take a look. Internet. What is the internet? It's a network of networks, right? Billions of connected host computing devices, host and the system running network apps. I mean, even if you're not taking any computer network courses that you know already. Nowadays, they try to add more things in, right? IoTs, Internet of Everything, IoEs, IoT, Internet of the Things, IoEs, Internet of Everything, etc., right? So your computer devices or your smartphone, at the networking term, we call that as end host, end systems. So when we're discussing in these connections, we used to call that as end-to-end connections. Connections between your devices. We often forget about what's in the between, right? And hopefully in this course, we can take a look at what's in the between. How, if you connect it to the Hanyang Universe network, how your packet from Hanyang University network goes to the outside, the campus, it goes to the other countries and etc. And you're running an app or programs. Internet Explorer is probably the most easiest program that you're running that requires internet connections, right? Communication link, fiber, copper, radio, satellite, blah, blah, blah. Fiber, 뭐지? What is a fiber? Optical cables, right? Cable consists of optics, which means glass, right? So it transmits a light. Copper cables, things that you use. Oh, well, these will come up later anyways. The copper cables that you use, like these, the Ethernet cables, or what do you guys call this? Other names? LAN-SON, or whatever, LAN. Coppers, so electric magnetic field. We'll discuss it later anyways. We usually take it as fiber, fast, copper, slow, radio and satellite, wireless. So there is no medium. Air is the medium to transmit the signals to it. And how do we measure the quality? We usually describe in terms of something called bandwidth, right? What is a bandwidth that you know? You guys don't use the term? Probably do. I mean, if you've seen a commercial by the cell phone companies, they usually say, or ISPs or telecommunication companies, that you can watch TVs without any problems. Under the subway, we can guarantee about 150 megabits per second, so you can watch TV anywhere in the subway systems, right? 150 megabits per second is the bandwidth, the term they try to describe. How much bits can you exchange per second between your device and whatever the end systems are? So, commercial 많잖아. There are lots of commercials that they measure it, and KT better than SKT in somewhere, SKT better than somewhere. Usually those metrics, the common metrics they use to compare the performances are bandwidth. How do we compute that? Well, it speaks itself, right? Usually they do this, right? Megabits per second. How much data that I receive divided by the time that I use probably gives you rough idea also on the speed. However, those telecommunication companies say that you can get 150 megabits per second connection over your LTE phones. Do you actually get 150 megabits per second speed if you try that? What is the maximum that you can get probably? What about the Hanyang University subway station? 얼마나? I didn't try. I don't have too much data in my cell phone, so I don't use it that much. But I don't know. If you're lucky, maybe 1 or 2 megabits per second, if you're lucky. So there are a huge gap between the commercials and what you're actually using it. Right? But everyone seems to be happy. No one seems to be complaining. Right? Yeah. There's a reason later why you cannot get what they say you should get in the real life situations. So this is a rough picture. Institutional network, this is us. Hanyang, think of this as a Hanyang University network. And it's connected to regional ISP. We have a few ISPs, typical ones like KT, Korea Telecom, SKT, SK Telecom, LG Telecom. Those are the major ISPs. So they say there's a link between the two. So Hanyang University must be subscribed into the, for example, SK Telecom's network to go outside. This might be your home. This is outside. It says global ISP. ISP referring to what? Internet service providers, right? Or sometimes they call it telco, telecommunication providers. They sell the internet, and it says global. There are bigger companies that have an access to the global internet. It's quite expensive though. I don't know how much Hanyang University pays to the local ISPs like KTS, KT, but it's probably at least a couple 100,000 per year. Yeah. Depends on how much the data that we use. Among these, much more expensive. Global ISP, anybody knows the name of any global ISPs? Oh, 손 든 거야, 이거 뭐야? What is this? You raise your hand or? AT&T is probably the biggest one. In the Asian area, I don't know, Hong Kong has PCCW. Those things are global ISPs. I don't know, NTT should be considered as a global ISP. NTT, which is a Japanese one, probably 10, I don't know the actual size, but probably 10 times larger than local ISPs in here in terms of revenues and etc. So this is us. And somewhere, probably this is ITBT building that we're in, this is your laptop. This goes in and out. That's a rough view of the situations. Wow, where am I? And there are some crazy things. When these things were there 10 years ago, they thought it's crazy. It seems to be these things is coming back again ever since the IoT things are going on. So there were some crazy fridge with the internet connection. I don't know why they had to build a fridge with the internet connection. There was even toaster with the internet connection. I don't know why they had to do it. It's quite common here though. Air conditioning has an internet connection so you can control outside your house, right? The famous story was one of the companies sells lots of those air conditioning. Someone hacked it right away so anyone can control someone else's air conditioning at home. So that was a problem before. And then these companies wasn't very successful and then it disappeared. Now it's bringing back again. IoT. They try to put everything internet connection. So in theory, you can make your toaster outside your home, but I don't know why you have to do that though. It's the over-engineering examples. Right. Protocols, the core part of the it's basically communicating between two things. How do we communicate each other, you and me? Right now, this is one-way communication. I talk, you pretend to listen, but you don't, so it's a very unfair one-way communication, right? But supposedly, in theory, we should be both ways, right? I say something, you say it back. And in terms of languages that we speak, there is a typically way to say stuff, right? If I say hello, first responses I usually get is a hello back. Or you can say something else, but usually those things are expected, right? Same thing. There are rules to talk to some other devices. That is something called protocols. So basically, it's a promise between the devices. I think next few slides we will go into that. Protocol control the sending, receiving the messages. Things like TCP/IP, which we'll be covering in other layers in more details. IP, what is IP? IP addresses that we discuss every day. I mean, certain numbers that representing your devices. That is also, IP stands for Internet Protocol. Internet Protocol. Skype, maybe not many Korean students using it, but if you're exchange, that if you need to talk to your friends back home or Skype, they have their own protocol of setting up the communication link. Right, am I speaking too fast? I had too many classes today, so I don't know. At some point, I don't see you guys. I feel like I'm seeing the. I'm high, very high today, so. So you stop me anytime. Ethernet, it's a lower layer protocol that is being used later. So each of these protocol names will be covered in class. And the very smart people come up with those protocols. But I will explain what protocol means, a bit more details next few slides. So internet is a network of network. devices consist of the network, and there are higher network that connecting those network. If you're connected, you need to talk to each other through this promised protocols. So your devices know how to talk to each other. For example, if it's supporting TCP/IP, it means they can follow the TCP/IP's protocols to communicate to the other devices. So internet, loosely hierarchical. If I draw this figure my ways, it will be more like this. Us, let's say IT/BT building. What's the total number of floors in this building? It's a 10th story building. 우리 몇 층까지 있지? No one knows how tall this building is, huh? Yeah, we always stay in the 3rd floor, so we don't know too much. I also don't know. Maybe 10th floor? 9층? Maybe. Let's say 9th floor, 8th floor. We are in 3rd floor. Each floor having their network. They're connected. Right? We're in 3rd floor. Within 3rd floor, we're room 302. This is our network. And when we try to access certain website like Naver, Google, then I need to go outside. We cannot do any connections within this building. Okay, this link goes to, there's other cables between the buildings, usually goes to engineering building 2, where there is a huge computing center. Engineering building 2 is this way, maybe? I don't know, it's only less than 1 kilometer apart from here. 얼마 안 되잖아. Not a kilometers, maybe 500 meters from this building. Let's say engineering building 2. Okay. And engineering building 2 has a nice computing center that can go outside. ISPs, local ISPs though. Local ISPs buys connection from global ISPs. I can't go up anymore. ISPs. Loosely hierarchical, we say. Just because sometimes these are connected to other global ISP in the same level. There might be other buildings like that. So in general shape is hierarchical structure, top down, go up. Public internet versus private intranet. Well, simply means if we talk to each other within campus, that's just private. If you need to talk to outside our campus network, that's going to be a public. Let's leave it at this point. There are more technical details to discuss, however, let's leave it at that. So there must be some type of organization to come up with those protocols and to agree upon how to connect each other, right? So there are things like RFCs, requests for comments. If you type it up, RFCs, then it's just documentation of a protocols that has been standardized. So if you want to build your own web browser, for example, you hate Internet Explorer, you hate Chrome, you hate Opera, you hate Safari, so you want to build your own. I don't know how crazy you are, but let's say you wanted to build your own. Then your web browser must be following some of the standard that is discussed in RFCs. Otherwise, your web browser won't be able to talk to any other web servers in the world. However, RFC doesn't cover technical implementation details. They are making standard ideas, so it's more like a promises. So even if you have the same RFCs, your implementation can be different. That's why we have different web browsers. Internet Explorer also follow many RFP documents. However, how they implement inside will be different from Chrome. Right? So sometimes some website showing quite well in the Internet Explorer, they don't show well in the Chrome. That's because this implementation details are different. But at least they can communicate each other. So. ITF, it's another organization. Bunch of engineers get together if there's a problem or they need to standardize something. That's the meeting place they can go to. Internet Engineering Task Force. So these are the go-to guys if you want to change the internet, if you want to propose a new standard of some of the protocols that you think you develop new protocol is much better than the ones that is being used now. Then you go to those ITF meetings, you insist that your thing is good, you present your ideas, and you have to fight for it. If you can convince these ITF, then your thing will be the next standard in the internet. However, the people who's gathering in ITF are very, very experienced, I'm afraid to say this in front of camera. If there isn't a camera, I would probably just say it. But somewhat crazy people are there. Yeah. Engineers, they have 20, 30 years of engineering background, and they go into these type of meetings. They actually fight each other. They scream at each other. And there are people hired by certain companies, like Samsung, hire someone to be in that meeting. And they claiming that Samsung's new standard should be the world standard. They fight for it. It's a very scary environment. So usually, typical computer science, networking people, long hair, don't take a shower, they like that, big fat bellies. But there are very popular, very famous programmers 10, 20 years ago. They built the internet itself. They fight each other. It's very crucial. For them, it's a money problem. If my new proposition, my new technique becomes an internet standard, it means they have to buy my devices in the future. Right? Cisco, Samsung, they fight for this. It used to be only US companies dominate everything. I mean, big companies dominate everything. Nowadays, like China's Huawei, and there are also very big companies, Asian-based companies, went to these meetings. It used to be they just sit there and didn't say too much because they had English problems and their technique, they weren't very confident about it. But nowadays, they also speak good English. And also, because they found that they have some of the language difficulties, they actually hire some Americans to fight for them. So it's very interesting meetings. I think it's, every year they only choose a nice cities to go to. Twice a year, maybe. I forgot how many times they have it. Unfortunately, I didn't have a chance to present or anything ITF, but my previous company that I was working for, there was at least 2 to 3 people attending these meetings regularly. I talked to them and etc. Yeah, I heard it's a jungle out there. You have to fight for it. RFCs, I'm gonna give it to you. Every protocol that we're gonna discuss in class, in your textbook also say RFP 182 discussing this protocol. They give you reference for this. So you can take a look at those documents. It's not that difficult. Just it's a matter of whether you know the term or not. Okay. Lots of information in last few slides, huh? Service view. Communication infrastructure enables distributed applications, webs, voice over IP, email. I'm sure you guys know this by now. File sharing, BitTorrent. Those of you exchange, this country, they block you certain BitTorrent files, so be aware. You might see a police webpage turning. You try to access some illegal website from this country. So be aware of that. Sometimes you see that. Also, be careful. BitTorrent network is keep monitored by the police. So don't download anything illegal or anything strange. Okay. but there is a way to get around it, so I'm sure you can find it in your own ways. Yeah. Anyways, so it's an infrastructure. Because it's an infrastructure, there are many debates at this point now, right? Like the example that I discussed in the first class, Samsung's smart TV and KT case. Korea Telecom provide the infrastructure, basic lines and everything. But however, they don't provide the content too much yet, right? Content is provided by the company like Samsung or Kakao. They are the one who's making money using this infrastructure, right? So there are lots of debate should be going on at the point. Communication service provided to the apps, reliable data delivery from source to destination. One of the key terms to describe the current internet service is the best effort. Best effort. What does that mean, best effort services? Best effort data delivery. And line before that, reliable data delivery from source to destination. Or I can say from end to end. Best effort. Okay. I think I'm saying a bit more than I should say in the first few slides. Later slide I can just skip if I explained already. Best effort. It seems to me the current internet would do the best to deliver your data. Another way of looking at it is there's no guarantee your data will be delivered. So there is no guarantee. Sometimes it's not the case anymore, but used to be if you send the file get lost somewhere in the between. If you try to compare best effort to telecommunication network, if you make a phone call, once your phone call is connected, it's guaranteed. You will pass out your voice to the other end. However, the current internet is so nice. I mean, nice is another term. It's big enough that it feels like it feels like a guaranteed delivery now. But in the core, it's still the best effort. We don't just realize it because the current quality is good enough for us to see it. Reliable data delivery is the same thing. Reliable. We can rely on the infrastructure that sends the data from one end to the other. This is actually the basic idea for when they create the internet. There are a few things they had in their mind. The initial developers of the internet, they wanted to make it simple. And they wanted to make it best effort. And they wanted to make it, I think those two were one of them. They wanted to make it very simple inside. Very rough overview of what's the internet. Very rough view. So things that you know, right? You probably heard many everywhere from news media and etc. Right? Or never heard about term best effort, reliable data delivery, ITF, RFCs. Never heard those things before? 한 번 들어본 적 없다. Raise your hand. Raise your hand if you never heard these terms. 진짜? So everyone has heard these terms. Or you simply don't care. I think simply you don't care. Fire and forget is another way of saying best effort. So fire and forget later we'll be discussing UDP protocols. So fire and forget is more like a military term. Right? You send your data and you run away. I don't care whether the data gets to the place that I intended or not. So you let the network take care of that. The sender usually don't care. That's fire and forget. Best effort here, network will do its best to deliver. But in this case, the user will be concerning whether your data is there or not. Okay. Yeah, so similar notation, slightly different, but I would say it's a very similar. Yeah. Fire and forget, that's very irresponsible terms too. I send the data, I don't care whether my friends gets it or not. it used to be like that. Nowadays, the streaming services are so nice. You don't see that happening a lot. Then more. Like a few years ago when 누구냐? 박지성. When he was playing Manchester United, lots of people wanted to see that game. But some of the Korean TV stations, they didn't play. But they didn't have a right to broadcast. So they used the P2P streaming from China. Many of them were China. And you try to connect to that service and you watch a very poor quality streaming video services, right? And fire and forget apply in that sense because when we're watching the streaming through those services, even if it was disconnected from frame to frame, we were happy, right? We're happy that we can still watch the game. Right? That notion is more like a fire and forget. We're willing to accept that, okay. If the frame was stopped, it means that data in the between got lost somewhere, didn't deliver into the right location. However, nowadays, even those streaming services are quite nice. I mean, there is not many UDP-related streaming services anymore. So you guys are living in a really, really nice quality internet service, period. However, inside is a mess. Inside is a mess. Anyway, so if you heard the term, you weren't sure that you probably heard something from the news, just let me know. If I know, I will explain as much as I can. If I don't know, I will just shut up, okay? So you can ask questions anytime. So protocol, what is a protocol? Humans protocol. If someone asks you the time, my usual responses are, it is 5 p.m. or don't ask me, or those are also valid responses, right? If you ask time to complete stranger, they will say, I don't know, don't talk to me, walk away. Those are the completely legitimate responses. I have a question also, then they say something. So specific messages to send. So what time is it is a promised message. So if I say what time is it, the recipient, another person understand what am I asking. Right? That's because we know what time is. Specific action tokens when messages received or other events. And certain messages can trigger certain event. The way. Networking protocol, almost same. Machines rather than human beings. All communication activities, internet, governed by protocols. Next slide, I actually have this, but let me draw it. This is what you do every single day when you're web surfing on any website. You or your PC, your laptop, server. Well, let me not use that word. Website. Pick out any. Naver.com. Naver.com may have a server. What do you do? What do you do if you want to go to the Naver.com? What do you do? Well, open up your browser and start typing. www.naver.com, enter. At that moment, you're doing this. As soon as you enter, you're saying, hello, neighbor. Naver.com must have a certain addresses. So I'm sending a message to that server, Naver.com. Naver.com received the hello messages from someone, probably you. Okay, I am alive. That's it. That's what they do. Say hello. Yes, I'm alive. Then usually answer again, are you sure? Something like that. To make sure before you actually sending a message to. Yes, I am. And then what do you do after you click on naver.com? You have your web pages, right? Web page contents is you keep receiving it. And once you receive the web page content, what do? You might be looking at some news that it might be interest to you. You click on that link. Maybe it's neighbor.com. I don't know, something, news. Understands it, give the data for the news this way. And they usually do request certain contents. And these messages must be understandable for both sides. I'm sending a request messages. You should be respond to me. Those things are promised in the HTTP protocol message formats, which is written in RFC documents. So your programs on Internet Explorer, web server program, must be able to understand what this means. That's why the current communication is possible. When we start discussing for the HTTP protocol, we're going to take a look at what type of message is possible from using these protocols. And everything is working this way. Hi, got the time to, that's a human way of doing it. Your textbook try to explain it with you a bit more detailed TCP connection, but it's almost same thing. TCP say hello, alive, okay, acknowledgement, data, get me this web page, sent. That's a protocol. Any other protocol that you know of have all this. HTTP protocol is a bit more complicated one. There are other protocols like 뭐가 있을까? NTP. 맞나? Yeah, NTP. Anybody? DNS는 나중에 나오고. NTP, okay. NTP. What is NTP protocol? Your computer synchronizes the clock every once in a while. There's a server that you can ask time. Server, your PC, send them in. What time is it? This is the time. Sync your PC to this standard time. So that particular protocol, very simple messages. Asking time, receiving the time. So it's a very light protocols that you can use. HTTP can do much more things, and other protocols do more. Skype, for example, I don't know the actual Skype protocol, but Skype probably the same. Hello. This is my friend's ID. Is he online? Yes. Can I connect? Yes. Like that. However, HTTP protocols, NTP protocols, those things are open. Skype protocol is hidden. It's private protocols. So are they open now? But initially when they introduced Skype, the protocol behavior was hidden inside. So people has to reverse engineer to figure out what type of messages they exchange. But nowadays, everyone knows the typical structures of the Skype because it has been studied a lot. Comparing to the human conversation, it will be much easier. We can ask the time in maybe 100 different ways, right? Comparing to that, this might be much easier. The rough idea on the protocols. So details will be covered in every chapter, every upcoming chapters. Network edge network, core and edge. Those are the typical terms that we use. Network edge, your host, your devices, smartphones. Those things are connected to the edge network. So us. Access network, bigger network like the Hanyang University network. It's considered to be, well, Hanyang University network is more of an edge if you look at from outside of the global network, but we can say it's the access network. Could be wired, could be using the line, fiber, or it could be using things like LTE or LTE, not WiMAX, whatever. So satellite communication if you have lots of money. Network core, what's inside? for example, between ISPs, network core. So, interconnected routers. What is a router? 들어본 사람? Anybody have a rough idea on what router is? 처음 들어보진 않을 거냐. It's not your first time hearing the term routers. What is it? Still, we're doing one-way communication. This, if I design this protocol, it would be really easy. I keep saying stuff. One way, you don't send anything. So.
Device provide access.
Right. I cannot say that's wrong, but it's right. When we start discussing the internet architecture itself, we have to discussing in packets, right? And packets, at this moment, it's a smaller data units that you generate. There's a computer, it's a computer software. It's a computer that figure out where to send those data to. It's a route. It finds a path to the next routers. So inside the core of the network is a connection between routers. It's expensive devices. And what's important is the information they have. So if I receive certain data, where should I send it to? Those things will be decided within these devices. So if you want, you can look it up the internet for looking for software routers. So some people implemented routers in software programs, so you can simulate a little bit too. There are many open sources that you can try. However, that's a later issues. So now we get the idea, right? And there seems to be a popular models of two, client and server, and what? Peer-to-peer. It used to be a very fancy term. Nowadays, everyone knows how this works. So, client-server model, simply, there's a computer that listens to, there's a computer that asks for the data. Client and server. Naver.com is big server. Your computer is a client. Peer-to-peer, well, if you download something from your friend's computer right away, directly. Or chatting applications. You send the messages directly from your device to other devices without any interference, without any servers in the between. It's KakaoTalk peer-to-peer or client and server. Assuming that everyone knows what KakaoTalk is. Pure client. What is it? Peer-to-peer. Raise your hand. Those of you who's now familiar with the KakaoTalk, it's like 뭐냐? WeChat? 뭐 이런 거? What is a similar tool outside? Huh? I don't know about Facebook Messenger. I don't use it, so I don't know whether they are peer-to-peer. WeChat, and what's in China? That's another popular one. WeChat is Chinese one. Yeah. Naver Line, or like P2P for KakaoTalk. You think it's P2P? Raise your hands. Client and server. Why? Why do you think it's a client and server? Yeah, we didn't know before. I mean, well, we could tell if we measured the packets, and we could know. But it was much more clear when a few months ago there was a big issues about someone monitoring all the KakaoTalk messages in this country, which will be impossible if they have a decentralized peer-to-peer model. Then we won't be able to monitor. It's a clear sign that it's a client and server model, which means that every message that I send to the Kakao server goes to the Kakao server, and they will send it to my friend's PC. So server will be looking at your messages, right? Even though they claim that they will not do it, but so that's why they made the announcement that they only keep messages, 15 days of a maximum week. Oh, and they also add another things like if the person who's sending the messages under the watch list, then they will keep the messages a bit longer than that. So another way of seeing that they are collaborating with the government somehow. So, 줘야지. 어떻게 안 줘. 나라에서 달라고 그러는데 주겠죠, 당연히. So there was lots of wiretapping issues on that part. So client server. Yeah. So by the way, one of the assignment I probably asked you for a very light KakaoTalk server client program. Yeah, I think that's assignment 2, 3. Yeah. So I will ask you to write a very simple chat server for that. Like I mentioned probably in first class, one of the very common programming assignment in any networking courses is a chatting application. I hated it. It's been assignment for 20, 30 years now. So if you walk into any networking courses, they ask for that. I didn't give it a few years ago, but I started giving the similar assignment last year just because I wanted to make sure that I don't want to be blamed for the guy who didn't give us a chatting applications in the networking courses. But it's going to be very, very easy chatting applications. Skype BitTorrent is also part of it. However, BitTorrent is a bit more sophisticated than just a simple peer-to-peer. BitTorrent은 어떻게 되지? Why BitTorrent so fast? We can download stuff from multiple locations, right? How is that possible? Seed 어쩌고저쩌고. Yeah, okay. Well, the main idea for the BitTorrent, I think, is they have the file in chunks. So if this is my movie file, they divide it into smaller chunk. I can give this portion to someone else. I can give this portion to someone else. This guy will receive the later portion from someone else, like that. And later, when they download everything together, you can merge from location. Right? There are examples of that later. Yeah, it depends on the network. Yeah, but usually it's a fixed chunk. 또 그거 변경해서 또 하는 애들이 있어요. So if you take a look at some of the hacking, it's not a hacking, but some white hacker try to manipulate a little bit of BitTorrent protocols. They might increase the chunk size and they download files faster than the others. 뭐 그런 게 있더라고요. I don't use it. By the way, if you use a BitTorrent in a campus network, you probably have a warning message right away. I received it a few times. They told me not to use the BitTorrent too much. My office. Anyway, this also we will have a chance to discuss it. Access network and physical media, how to connect the system to the edge routers. So if I draw it, there are ways, if I draw back that ITBT building, there's a device to the engineer building 2. There's a big device, goes outside the global ISPs, routers. And here, we don't call this as router too much. We call that as a switch, but we will discuss about that, the difference between router and switch. But nowadays, it's almost combined, though. Expensive. I don't know too much details about Hanyang University network. It's somewhat classified. They shouldn't be revealing the type of devices they're using it or network itself. They're just afraid someone might use that information to hack in. But 이런 거, maybe Cisco 6500 series 얼마나 되나? I don't know. Close to maybe $60,000 to $70,000 per device, just for the device, and you have to purchase another interface too. 한 6, 7천만 원 할래나? I don't know. Those devices are all different. Residential access net institution, us, mobile access network, Hanyang University LAN, wireless LAN, HYU WLAN, which shows a very poor quality all the time. Keep in mind that bandwidth, bits per second of an access network, shared or dedicated, there are many other issues to do it. And I think I'm gonna skip a few more slides, like dial-up modems, which you guys probably never used it before in your generations. 혹시 써본 사람? Anybody has experienced a dial-up? Even your generations? Really? My modem, my first ever dial-up modem, I think it was when I was 8, 9, maybe 8, 9. The first one, like 12.8 kilobits per second, so it's very slow ones. I think I was around even before 8 or 9. That was my first modem that I had. But even if back then, even if you have a modem, there was no internet, no clear internet, so there's nothing you can do unless you do a stupid chatting with a small website. So this is not your stuff, but it used to be using a dial-up modems to do a data exchange. However, dial-up is using a telephone network signals part. DSL as well. We're using a special devices to use a telephone network signals. Why are those things were slow? Why they're using a telephone networks, and this says it's too slow. Maximum 12.8, 56. Later there was modem 128 kilobits per second, if I remember correctly. But that's very slow. Why was it slow? Yeah. Telecommunication network was built in analog circuit signals. Simply means this. I'm not a physician, I'm not an electrical engineer, so I don't know too much about signals, but I only know the very basics. Signal travels, so they can, if I speak now, my voice will be like that and get to the end of the room, right? Same thing, telecommunication network was carrying your voice in this analog signals, right? Problem was, in order to send the data, we had to manipulate the signal in this way. 0101 on top of this type of signal. So there was lots of noise. It wasn't very inefficient because we're borrowing this. Obviously, this is a continuous signal. The shape wasn't clear. And we try to do this on top of this. It's curvy lines, so it was slow. That was a modularization. We try to put a data on top of this analog signal. So it has a difficulty from the birth. Later, it's become a digital signal, so we can do it better. So that's a rough idea. I think we might have that too. But it's okay. We don't need to understand that. One of the good things about telecommunication network is once you're connected, you will not be disconnected. Circuit switching means there is a dedicated circuit. It's reserved for you. If you're using it, no one else can touch it. No one else can touch it. However, it has a problem of capacity. What happens, lots of people start calling in 911. Maybe bridge collapsed right here. People start calling ambulances. After certain points that 911 cannot answer you. Why? Because too many phone calls into the 911. The line is full. You cannot have more calls. It's above its capacity. So there's a two side. Once it's connected, Delivery is guaranteed. However, there's a limitation of how many calls that you can have. That's a telecommunication network lines. Internet, it's opposite, right? We can send as many as we want, but it's going to be slow if we send too much. Again, that's a difference between dedicated and best effort. Best effort. We'll get to that again. 그때 이런 거 많이 했는데, 이런 거 게임 같은 거 많이 하다가 채팅하다가 엄마한테 걸리고 막. 왜냐면 이때는 돈을 받았잖아. At these times, we're using telephone lines to chat or internet. So it's money. How long you're using your telephone? So your mom scream at you and stop using my phone. You're not making any money, and etc. My generations. 밤에 몰래 하고, so you do it secretly when parents are sleeping. But we don't do that anymore. Ever since the faster dial-up modems with DSL lines, its speed obviously much faster, 1 megabits per second upstream, 8 megabits per second downstream. What is upstream and downstream? Well, up and down. Because you guys always download, right? We are all usually concerned with the download speed. There is also upload speed too. If someone comes to you and get the data from you, right? So there is, in this DSL lines was, upstream capacity was low. However, download stream is high. Even now, the companies wanted to control your upload speed. So if you read your ISP contract carefully, the ones that you use at home, somewhere in there they wrote a very small letters, do not run the servers in your homes. If you're running a server, if you're lucky, then your server gets really popular, people start flowing in, and then your upload will be large, right? That's against the contract, right? If you're hitting that stage, then you have to purchase the extra lines to serve your data. Anyway, that's the story for now. This LAN, DSL, dedicated physical line to this telephone. And then fiber optics, even larger. Simply put this, in Korea, building to building is now all fiber optics. Only within the building it's a copper, right? However, there are many countries still, the building to building still copper and solar lines. This is a very unique country. We spend lots of money on building this type of network for years now. 별 내용이 없다. 막상 놓고 보니까. There is also a competitor. If you try to purchase a internet service at your home, what options do you have? Huh? I don't think anyone uses the ADSL anymore. It's 15 years ago, 20 years ago story. Nowadays, you might have a choice you can buy an internet connection from your local cable providers, SO. Right? So they use a different type of cable to deliver your data. It's quite fast too. Cable 3.0, those type of new protocols, they can support up to 300 megabits per second, even higher. So they are a good competitor to the fiber optics cables that you can purchase. 그리고 뭐 이런 거 나오는데, it's a core network stuff. IP over SONET, ATM, WDM, this is too much for you. Just mentioning OC12, OC48 is those type of cable is connecting between cities, for example. Connecting between cities. OC48 is up to 2.4 gigabits per second. OC 128, I forgot the name, but those things nowadays can support up to 100 gigabits per second between the cities. 40 gigabits, 100 gigabits per second. Imagine that you install a 100 gigabits per second cable between two cities. How much data that you can get per second. in that cable. Only rich countries have that now. Like 어디 있더라? There are still pilot studies. 뭐 어디랑 어디? 뭐 LA to San Diego. Like that. They install 100 gigabits per second lines. 한국에도 있을걸요? Maybe in Korea there are a few locations testing that. However, this is no longer a technical issue. At this point, it's more about business issues. If you install a 40 gigabits per second line, can you make money out of it? I doubt that. Anyway, I just wanted to show you the general pictures of the part. It's okay, I will skip this. Huh? 내가 왜 넣어놨지? So if there is a slide that I skip, you can skip it too. I'm not going to ask any questions from this slide. Ethernet is a typical protocol that we use, right? Landline, 뭐야 또? 또 뭐라고 불러? What's the another name for this? What do you guys call this? 랜선. Any other names? 뭐 따로 안 불러요? You guys only call this as a landlines? Huh? It's called an Ethernet cable, right? Ethernet. Ring a bell, huh? Ethernet is a protocol name, lower layer protocol. So we call that as an Ethernet cable, more friendly term. They all have the names too. This head too. What's the name of this? Anyone know? Head. Oh, RJ45, and it's all garbage names, so you don't have to memorize that. So Ethernet cable is a typical. There is a reason that the lower layer protocol was using a Ethernet. It wasn't a technically advanced. It's more about the cost. Ethernet chips were much cheaper to produce. That's why it was become a dominant technology at the end. Of course, in the link layer technology later, the lower layers, we're going to discuss about Ethernet protocol, how they actually work. And for now, I mean, this building, obviously, we're using 100 megabits per second or 1 gigabits per second Ethernet cables to connect to the Ethernet switch. And then it goes to somewhere in this building, has a switch to the outside the building. So if you want to do something bad to the internet connection in this building, find some room, door locked. It's probably inside some devices are going. So you can unplug that room, then entire internet in this building at least will go out. So I saw that in this building. Sometimes it's unlocked. So if you're searching for the chance, then you can go. I also, in my apartment, my floor has the room that filled with the switches that's connecting to my apartment building. It's right in front of my house. So I walk outside in the morning and I saw that door unlocked. Someone opened it. I was thinking, if I put my device into that room and unplug my computer into one of those switches, I can hack into anybody's computer in my buildings. Right. Physical security is also a very important part of it. So somewhat we're careless. My last year's information security courses, I don't know anybody have taken. I take out some of the cables from that spot and I monitor. I set up a fake AP for you to connect in. I was collecting all the packets for testing purposes. Yeah. But it's illegal. I shouldn't say this in front of a camera, but it's illegal. It's against the law. But for fun, though. I'm going really easy because things that you know already, you guys probably heard. Shared wireless access network connects to the end door. Wireless LANs, 802.11bg, sometimes called Wi-Fi. What is that? 802.11. We see this from the boxes if you purchase the sharing devices. It says our device supports 802.11 A, B, G, N, AC, like that. What is that? What does that number stand for? Yeah, it's also a type of. IEEE defines such a protocol formats. So if you type on Google IEEE 802.11 ABCD, then we get you the technical paper to implement this wireless protocols. Anybody know the number for WiMAX, Vibro? If I remember correctly, 802.16 or something. I have to look it up. My memory is really bad now. They all have the numbers too. 802.16, yeah, I think it's 802.16, it's all numbers. You can even find the Ethernet numbers for the 802. Some number. You can look it up. It's all written there. So everyday life, you're using this term, didn't realize that you're referring to a protocol names. Protocol names. Wider area wireless network. EVO HSDPA is now long gone. Now we're onto LTEs and etc. So WiMAX or Vibro was also a competitor to the LTE, but now it's almost dying. So Korea invested $1 billion for WiMAX technologies. 2 billion almost. 2 billion. Not dollars. 2 billion 원이니까 1점은 얼마야? 1점은 영어로 얼마야? How much is 1 billion won in US dollars? 몰라? No one seems to know. Anyway, lots of money to WiMAX because we thought that's going to be a standard. Well, it is a standard technology, but they believe that it's going to be the market dominant technologies, WiMAX. So we spent lots of money on that part, but LTE is taking over right now at the point. Samsung still do it, but 아마 삼성이 2조인가 됐을 거예요. Samsung spent about 2 billion wons on that particular technology. POSCO spent about 1 billion wons. That's lots of money. 포스데이터가 왜 없어졌어요? 와이브로 1조 투자하고 날아간 거예요. 네. 포스코 ICT로 이름 바뀌었죠. 그때 여러 사람 실업자 될 뻔했죠. 잘못된 결정이 한 사람의 결정이 3조가 날아가는 거예요. 잘못하면. 그만큼 정책도 중요한 거예요. 우리나라에서 막 밀었다고 그냥 밀어붙였다 그냥 아작이 났죠. 그때부터 LTE였으면 훨씬 낫을 텐데. 그래서 딴 데 쓰려고 하잖아요. 뭐 재난망에도 어떻게 써보려고 하고. 근데 열심히 해봐야 사람들이 안 하니까. Okay, so few more slides just to read it through, just simply because we're gonna discuss it again. Just now we discussed with the wireless ones, and if we stick with the physical media, it's the guided lines, something called guided lines. If it's guided, obviously it will be faster, less noise to the transmissions. So bits to propagate between transmitter and receiving pairs, transmit between the two ends, physical link, what lies between transmitter and receiver, guided media, signal propagates in solid media, copper, fiber, and coax. Okay. We can do this easily for this type of cables, right? We can bend and everything. If you do this for the fiber cables, it will break. It will break. It's a glass. So lots of people misunderstand. I've seen they carry things like you carrying these type of cables. If you break the glass, then it would not be able to transmit the light. Then you will have a difficulty of getting the data. It will have many noise. Means if there's too much noise, then end user will feel that it will be slowing down, just because noise has been introduced, then you have to send that data over and over again until you get it right. So unguided media signal propagates freely like a radio, the air, twisted pair, blah, 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 category 3, category 5. No need to memorize. It just Ethernet cable is just fine. Just giving you some general ideas. Coaxial cable, like old cables, like the cable provider internet like that, and fiber optics, glass fiber carrying a light pulses, each pulse 8 bits, and it's easily up to 10 to 100 gigabits per second speed, and obviously faster, and low error ratio. Repeaters placed far apart. So if you want to send the data from one location to the other, the distance is large. You have to put something in the between. Many of the cases, you have to boost up the signal. There's something called repeater. However, in optical fiber situation, the traveling distance are also big, so they require less repeaters. So hopefully it introduces less noise to the data itself. 그런 거 많았잖아요. When I forgot the name, the Snowden guy who revealed NSA's things, and one of the things he revealed was there is an office nearby the West Coast, and then there is a room full of this fiber optics cable that is coming into the U.S. and it's going into some rooms, and they have used a certain device to copy. Well, copying is not the right term, but copying this signal to another PC, they monitor. They try to filter in hundreds of gigabits per second data in that way. They confess, but it's possible. However, how do you copy a light? There are devices that you can use, but light, simply you can just split and the light will be the same. So that's how they copy the signal. If you're using a coaxial or copper cable, then you need to actually copy the signal itself. So you need the extra electric sources to copy it. Light, simply divide. Anyway, that's another story. When I was seeing the news, I was surprised. If you wiretap a 100 gigabits per second fiber optic cable, how much data do they get? It's amazing how much they can proceed. I mean, it's not about the speed anymore. I was wondering whether they have a good enough hard disk to write all the data in. Hard disk is slower, much more slower than 100 gigabits per second data. So I was very surprised to hear that. Well, anyways. I think I explained it. LAN, terrestrial microwave, satellite, wide area network, 3G or LTE, LTE plus. Terrestrial microwave, 저건 뭘까? Does anybody know what it is? I'm not so sure it's being used because of the satellite. Typically used in Korea, typically used for the situations like island, small island. Korea. No internet here. Anyway, there are many islands like that. And because if you try to install this physical cable to the island, small island only lives like maybe 100 people. That's a lot of money to invest, right? So I mean, you have to install a cable underwater and you have to install a router. That's too much. So in certain cases, there's island, they put a small antenna looking like devices using a microwave to send the data in. One of the things that have to be careful is those antennas has to face each other. This antenna this way is facing this way, they not have a connection. So they have to face each other. So one of the ways to provide networking services to in these situations. Nowadays, satellite is more of a choice. However, satellite communication is a bit expensive. So I think they're getting some government aid because they cannot pay themselves. So government paid some part of the satellite communication to provide a internet service to this type of island. Expensive. Then more. Nowadays LTE coverage is quite good, so lots of islands using LTE instead of satellite as well. Plus, if you're using the LTE like signal in the ocean area, the coverage doubles up. I mean, it doesn't have any buildings, so it's really have a good coverage. Anyways. What else? That was a very brief overview of the network edge. Different techniques were being used, and etc. Network core, circuit switching, packet switching, or network structure. A bit more technical now. Meshes of the interconnected router. The core part is this. You can even find the map of router connections in the internet. You can find those maps too. If you're looking up the map, do not expect a map. It's more of everyone is connected to everywhere. It's a really mess graph that you're expecting. I will show you from some time. A fundamental question is, how is the data transferred through the network? How, if I send something to this router or switch, how does it know where to send it to next? It might be ending up in here, it might be ending up in here. If my data gets to here, this one knows where to send. How is that possible, right? Circuit switching, for the first hand, is dedicated circuit per call, telephone network. So when you try to call somebody, what's happening? If you punch a number, press call, what's happening? You hear the ringing, right? Ringing. And then the other person received it, ringing gone, you can talk to each other, right? In the ringing state, you already found the path to the another person. Once it's receiving the phone call, that path is now yours. No one else can interfere. I mean, it's not a good graph for the telecommunication circuit switching. That's the one part. Packet switching, data sent through the network in chunks. You're sending, I don't know, like the BitTorrent examples, you're sending a 1.5 gigabytes bytes of a movie file. That movie file will be into a very smaller chunk, for example, like 1500 bytes. And each one will be sending through. And some of them will take the different path. Some packets, my destination is here, this is me. Some packets may go here, some packets take a different path because I'm sending up chunks. So those are some differences of that part. Next slide explains that end-to-end resource reserved for the call. Before we start communicating, path is reserved. It's not going to be changed. It's mine. Link bandwidth, switching capacity, dedicated resources, no sharing. I'm not sharing any other end host with that link. That's mine. Circuit-like, also called guaranteed. Best effort internet, packet switching, best effort. Circuit, guaranteed. Downside, call setup required. You have to set up a call. You have to set up a path before you send the calling. That is extra steps to have, which is a more waiting time before you sending your data. In the internet situation, do you wait? You just send, right? You don't wait for those setting up period. You just send. Hopefully it gets there. So those are the major differences. Circuit switching, network resources divided into pieces allocated to calls, resource idle. 뭐야, 내가 뭐 하는 거야? Oh, why is this slide first? In the circuit switching is also, you can divide the resources into chunks too. The example that I had in the file, I'm dividing the datas. In this way, in this circuit switching pieces are dividing the resources, dividing the, for example, frequencies and time. Don't mix it up. So there are two ways of dividing link bandwidth into pieces. Frequency division and time division. Frequency division, FDM. I'm sending some signal, wow. Time, wow, right? Frequency division, there are maybe 4 users. They divide the frequency. Maybe user 1 sending the signal like that. User 2 sending their signal a bit larger, like that. So they divide the frequencies to share. This way. Like that. So there may be a limitation on what's the maximum number of users that frequency can take. And it has to be arranged beforehand. If the user 1 wanted to use this frequency, they have to let the other know, I'm using this frequency to send you the data. So it has to be pre-set up, right? Or time division multiplexing. Frequency is that instead of dividing the frequencies, we're dividing a time slot like that. So each slot, one person can use it. One person. If one is using this slot, the other must be waiting, for example. But hopefully the switching is fast enough that no one seems to be delaying too much. 2 different ways. This is very nice distribution. If someone wanted to take more, then the other may have to wait. Or it may not be fair in certain cases. Right? These type of talk, you probably hear that when they discussing CDMA. What's a CDMA that our cell phones were using? Code division multiplexing. They used a special code to figure out how much that you send coding. China has their own standard for the LTE. TD, I think TD, what was the name for that? TD LTE or TD GSM. So they had a time division ways of doing it, which is slightly different from our standard. So problem comes, not the problem, but the question comes, if we're using a circuit switching network and this circuit, let's say, you're going to use a TDM approaches to send the data from one to the other. So how long does it take to send some files from one to the other location using TDM link this way? How long does it take to send a file of 640,000 bits from a host A to host B over a circuit switch network? All link speed is 1.536 megabits per second. Each link uses a TDM with the 24 slots per second. And there are 500 milliseconds to call setup to do it. How do you calculate this? How do you calculate this? I don't know. It says 24 slots per second, and single second they can send a 1.536 megabytes per second. And I can use a single slot to send to somewhere else. What would you do? 뭐 그려보면 되지. I can draw it. By the way, this is most likely looking at your midterm questions or your assignment, like very easy ones, we'll say. 1 second, let's say 1 second. 1 second period, I have 24 slots, right? How much that I can send in a single slot to PPS? How much that I can send? Yeah. This is 1.5 megabits per second. Okay, I would just simply divide 1.536 megabits per second divided by 24. Someone do the computation for me. It's okay, I have it right here. Single slot can send 64 kilobits per second. How much data do I need to send? How much data do I need to send?
600.
Right? 64 kilobits is bits per second. I can't believe I'm doing this. BPS. How much do I get? 10 seconds. I'm sorry. Right? 10 seconds. I need 10 seconds to send data from A to B. However, I'm missing something too. What am I missing? Huh? Yeah. Before I send, I need the time to call to set up 500 milliseconds. That's 0.5. That's how much time that I need to send this file using TDM link. So you can see it as another 1 second. 24 of them. 10 of them, I'm sorry, 10 of them. Then I'm done sending the file. Right? Does it make sense? Simple math. If I change this to a distance problem, from Seoul to Busan, that's 640,000 kilometers. I can only drive a 64,000 kilometers per second. How much do I need? 64 kilometers per hour, how much do I need? I need to drive 10 hours. Right? Before I drive 10 hours, I need to buy the tickets, which is another 5 milliseconds, 500 milliseconds. Add. That's how much time that I need to send some amount of data to over this TDM link to someone else. Exact same explanation is given in your textbook. This is an example from your textbook. However, they don't explain that well. I mean, they don't discuss it too much. They just say, this is this, you need 10.5 seconds to do this. The reasons they don't explain too much is I think they thought it's just too trivial to explain. Okay. But last time I asked the exact same question in the exam, lots of people leave it blank. I don't understand why in certain cases. However, this hopefully, again, this might give you the taste of what your midterm exams will be look like. Okay? 왜 갑자기 no one seems to be interested anymore? 아주 간단하잖아. 내가 100km로 운전할 수 있는데 뭐 1시간에 100km밖에 운전할 수 없으면 뭐 총 가야 되는 게 1000km면 10시간 운전해야 되는 거예요. 그 얘기예요. 똑같은 얘기예요. Because I'm sharing with the others with this slots. It's much easier to interpret this as a distance problem. Then people, they can do it right away. But if I just change the units and it's become I don't know why, but it becomes more and more confusing problem somehow. Anyway, we will have lots of different chances to discuss problem like this. Later, we will have to discuss probability. Things like there's a 10 people using the link, sharing the link at the same time, but there's a probability of that not 10 people using the network all at the same time. So let's compute the probability of 3 people using the network at the same time. How much people that I can hold in this link? They use a probability to calculate the maximum possible number of people they can share, and etc. What's the maximum speed that I can expect from those type of link? We'll be looking at more examples like that too. Each end-to-end data stream divided into packets. And now it's a packet switching, not a circuit switching anymore. Users A and B packets share the network resources. Each packet uses the full link bandwidth. Good. Packets will use every bandwidth available. We usually draw bandwidth like in pipe. For example. And we start throwing in a chunk. Things are floating in this chunk. Resources are used as needed. Bandwidth division into pieces dedicated. Oh, that's okay. The resource contention, aggregate the resource demand can exceed amount available. This is how much I have. Maybe this is good for 10 people. There's another 10 people start joining in. What do? I cannot shut them down because it's a sharing link, right? That's why there is a problem with something called congestions. More people try to send the data into this. So later chapters, when we're discussing about TCP protocols, TCP takes care of this type of congestion control problems. So they will take control of who can admit into this trunk, while being fair for everyone else too. So at this point, we're going to just say the concept of congestions. Packet is queued, wait for the link use. I'm just drawing as they told me. What is a queue? 설마, queue, data structure queue, right? First in, first out. Queue. Packet comes in, goes to the front. It has a chance to go to the link, go. Simply say, what if the queue size is not big enough? What do? Packet keep coming in. Data chunks keep coming in, but packet size, this queue size is not big enough. What do you have to do? Or in this case, they don't care. They don't consider for the queue size yet. Queue is big enough, but later arriving packets may have to stay here too long. It's waiting time, right? We don't want to wait. Waiting means we'll be slowing down your data transfer. Congestions. Store and forward. Packets move one hop at a time. Router. One at a time. One hop. And router is basically a queue. Link, router. Another link, another queue. So how many queues are you jumping? How long you're staying here? How long does it take to go to another queue? Also, how long you're staying here? If you add this all up, this will be the time that you have to send the one data to another. So we will be considering that as a delaying factors too. Because if you simulate the routers and the internet in general, it's just queuing theory. You can even write a simple simulation program using queue to giving a random waiting seconds and etc. And you can calculate how long for user A to send the data to B, how long does it have to A wait to get the responses back, and etc. Store and forward. Node receive the complete packets before forwarding. Everything has to be in here. There are many issues in this part. These routers, things that you buy, software routers, they have a mechanism for if your router is running out of queue, what do you do? What can you do? If your queue size is not big enough, more packets coming in, what do?
You reject those packets?
That's probably first option. They will just drop it. They don't accept it. For the end user point of view, your data got lost, but you don't know where, right? But in terms of end users, they have another option. If they can detect that my data has been lost somewhere in the network, I have an option to send it again. So I'm hoping for there is a space for the queue or whatever, the conditions will be better for me. Those things are actually defined on every protocol that we're going to discuss in this course. Mechanisms. Very simple. This is actually the core part of the network, internet. Store forward, store forward, store forward. Nothing else. So again, initial internet architectures, they wanted to make the core network very simple. Nothing but store and forward to the right location. 아, 여기 다 있구나. I think next few set of slides explain this all. I explained too much in the first slide. So 100 megabits per second Ethernet cable, it's going to be on the queue router switch. It would take its chances to go to whenever they can use the sharing. Queue packets waiting for the output link, like that. Whenever they have a chance, they would use this slot to go to the next location, another queue, and hopefully gets there. Sequence of A and B packets has no fixed time patterns. Bandwidth share demands, statistical multiplexing. Statistical multiplexing, we will be discussing that. Like the example that I briefly mentioned, that assumption is not all packets will be coming to this link at all the time. So we can nicely distribute. We expect nice distribution of the packets, so we can minimize the link usage while providing a maximum connection qualities. Anyway, we can also discuss that later. This is too much information for the first set of slides. I didn't realize this. Like I mentioned, if we do a backward, if we do a bottom-top approach, it will be much more confusing. So, like I told you from the beginning of this slide is more about introducing the terminology. So I can use this term to explain stuff later chapters, okay? 뭐 이렇게 많아? Simple calculation examples. Packet switching, store and forward takes L divided by R seconds to transmit. Maybe that's a rate, bandwidth. You can take a look at it as R as bandwidth. L is the data. So if I divide the data by the bandwidth rates, I have a time, right? So packet of L bits on top of the link on R BPS. So basic question is, how long do I have to wait if it goes to a 1, 2, 3 hops in order to get from one end to the other? Very simple question, right? 3 hops.
1.5 times 3 plus 15.
Right? Yeah. Divide, yeah. 3 times L divided by R. It's obvious, right? Because it goes 3 different links, right? Assuming there is no other delays like propagation delays, which we'll be discussing for physical reasons and etc. So entire packet must be arriving at the router before it can be transmitted onto the next link. So one by one at a time. If you can add this number in, you probably have 15 seconds to do it. L을 R로 나누면 1, 2, 3. And they also give you a condition that this one will wait until they receive L fully. L fully. Go. So it's a very simple formula. 3 times L divided by R. this is a very easy case to take a look at. 야야야야야야야. 슬라이드가 좀 뒤바뀌었다. There is a problem with the ordering of the slide. I should have discussed this later. It's okay. I will discuss this slide in next week anyways. But packet switching versus circuit switching. Packet switching allows more users to use the network. Circuit switching, like I mentioned, there's a limitation at the beginning. If my circuit only can hold 100 people, that's it. But circuit switching, they should host more. How is that possible? This is 1 megabits per second link. Each user sending 100 kilobits per second when they're active. However, they're only active 10% of this time. How do you calculate the probability of something like this? There's 10 people sending data to this link. 10. It says they send the data only when they're active, but 10% of the time they're active. What's the probability of all 10% is active? So 10%, 1 over 10, 1 over 10, 1 over 10, 1 over 10. What's the probability of all 10% is generating data? 아니. Each user, 10% of the time, they're active, means they will generate the data. And I'm asking for the event situation where all the 10 users generating data. Huh? Yeah. You just. Ten times, right? 10 times. That's the probability of every user is being active. Makes sense, right? It's a simple dice problem. So if I roll a dice, what is the probability of rolling a 2 dice showing a 1 both end? So they use this idea to, because packet switching network with the 35 users, probability of more than 10 active users at the same time is less than 0.004. So they can guarantee a certain type of quality in this way. How do they compute the 0.004? Similar ways that I did. And you can take a look at your textbook. Anyway, I will discuss that anyways in the class too. So I ask you to read that part. I think this probability is given prior to researches. 이게 왜 먼저 튀어나왔지? 내가 슬라이드를 잘못 오더를 했다. Circuit switching, 10 max. This, 35 at least. However, if it's worst cases, all 35 users may be active. Then you may not guarantee the 1.5 megabits per second speed. Everyone has to share. 35 people sharing 1.5 megabits per second link. That's a lot less than sharing by 10 people, right? So what's better? Is it packet switching better, circuit switching better? 응? 케이스 바이 케이스. 그래, 여러분들은 무슨 케바케 이런 말을 쓰더라. 처음 들었는데. Case by case, maybe, yeah. Unless we change the packet switching nature of the internet core, there's no way we can make this as guarantee. However, we like to make the packet switching network acting like a circuit switching, because circuit switching is guaranteed. That's a dilemma that we have. Is packet switching is a winner? It's certainly useful for the cases like a bursty data. If you want to share the resources to many users, then the packet switching should be way to go. However, there is no guarantee that we can guarantee certain quality all the time. So excessive congestion, packet delay, and losses. Protocol needs for reliable data delivery. Congestion control mechanism must be discovered. How to provide a circuit-like behavior. We wanted to make a packet switching like a circuit switching behavior, guaranteed ones. Bandwidth guaranteed need to be for audio and video clips. It is a still unsolvable problem. Lots of works to do that. And what they're saying for the video and audio apps, if it's possible, video and audio packets, we might guarantee certain bandwidth, minimum bandwidth, if it's possible. There are certain mechanisms that you can do it in the core network. They make the class of the packets, so they try to guarantee certain level of bandwidth. However, it's not always guaranteed, just like the packet switching nature. I realized that I was going too fast about packet switching and circuit switching. Yeah, too much information in a single slide. I will review it again. I will try to go over some of the slides next week as well. So don't worry if you don't get it at this moment. Yeah, this last 2 or 3 slides should be at the end of this slide. I was making a mistake. Internet structure. Go back to the bit less technical stuff. It's for fun stuff. Internet structure, network of networker, roughly hierarchical. At the center, small number of well-connected large network. Tier 1 ISP is the big one. Global ISP usually called as a tier 1, like Verizon, Sprint, AT&T. Level 3, they do a national to a continent to continent connections. So they're selling the network to the nations and bigger regions and etc. And there are large content distributors like Google, Akamai. Akamai is the biggest CDN, content delivery network providers. Or Microsoft also do it, but I believe the Microsoft use lots of Akamai network to do it. Treat each other as equal. So among themselves, they don't charge each other. Well, in certain cases. So if there's a traffic that needs to go to this guy, they don't charge each other. But if they sell their traffic to the lower layer ISPs, they will charge. They will get the money. That's how they make money. Ever since the Korea TV stuff was popular, I mean, lots of people in Asia watching those TV shows in Korea, there were too much traffic going outside from Korea to overseas now. But in order to do that, we have to pay this global ISPs a lot more money. So it was a big concern for now. We'd like to minimize the money that we're spending on this network. 아니면 Akamai, things like Akamai, Google. Why do they say Google is a large content distributor? In this slide. YouTube is Google's, right? They have to store their video clips somewhere in the network, right? I mean, if they only store the video clips in the US, if you try to watch a video clips from here, it will be slow. So it used to be if you try to watch a YouTube clips within Korea with very high quality, wasn't possible because the ISPs in this country refused Google. Don't come to my country to steal my network. So they refused to accept a Google's YouTube servers. They couldn't put a video clips nearby. However, I think Google is now in the country. So they buy certain spaces in the ISPs. Now you can watch those video clips a bit more easier because we have replications. Akamai, things like Microsoft Windows Update. Anywhere in the world, if you click on Microsoft updates, it's fast, right? Microsoft give their update file to Akamai. Akamai will spread their network so they can access it anywhere. The country size of like South Korea, it's a small country, so content provider didn't make too much money back then. Everything is in Seoul, so what? This is a very small country. Even if you connect from Busan, you still have a good quality, right? But countries like the US, it's huge. So they have to distribute the content into the right network. So they buy the spot within the ISPs to put their files in. 아마 구글은 돈 안 내고 들어왔을걸요? As far as I know, Google didn't pay a single dollars to move into Korea. What the ISP is afraid of is Google just buy some ISP, they building their own network. That is the biggest fear in this country for now. Google can buy anything. They can buy LG Telecom, SK Telecom maybe not. KT no. But for radical cases, Google purchased LG Telecom and they can sell internet service connections at the same time their contents too. That's the biggest fearful scenario had by Korean ISPs at this moment. 그냥 하면 돼. Google can do anything with their monies. Yeah. I think in the US they start business like Google Fiber services. They start selling the fiber optic connections, the internet service to homes. However, it's a very limited in certain regions. I don't think they have their own network. They borrow the network of existing providers to provide the service. But if they move in here, they can purchase any company they want. They can do it. Sprint is now owned by SoftBank, Japan? 맞지? 스프린트 맞지? 아니야? 내가 잘못 아나? Sprint is now owned by SoftBank, which is a Japanese company. The owner is Korean, but he doesn't speak Korean that much. 그래서 그런 거 했잖아. What I heard from a Japanese friend is if you're using a SoftBank phone, it's also telecommunication provider in Japan. If you're using a SoftBank network in Japan, if you try to call your friends in the US who is using Sprint, it's like a local call now. It's no longer international phone calls. Very smart guy. Very strange, but very smart guy. So hopefully that gives you some stories about how these biggest ISPs are moving around and what they wanted to do. On the other business side, ISPs nowadays wanted to be more content provider because their fear for the content provider will taking over their network soon. 카카오 이런 거 얼마나 싫어하는데 KT, ISP, they hate Kakao Talks. 얼마나 싫어하는데. They look at them as companies who try to take advantages of their own network. There are terms nowadays they use is OTT provider. Anybody heard the term? OTT? Such as a Kakao Talk or any type of chatting applications that use the existing network to make their business. It's called OTT service now. 요즘에 이 말 많이 써요. OTT service. So KT, SK Telecom, they hate OTT service providers, and they wanted to be OTT provider as well. 근데 KT 메신저 만들다고 쓸까? 안 쓰겠죠. 그렇죠? 근데 열심히 삽질 많이 하고 있어요. 좀 해보려고. SKT는 뭐 말할 것도 없고. Tier 1 providers, So Tier 1 ISP content distributor interconnected peers in this way. They're connecting each other. They're usually connecting through something called Internet Exchange Point, IXPs. There is something called KIX, Korea Internet Exchange, or there are Japanese one as well. If you walk into that room, there is you have routers and you have a cable from all these biggest ISPs. You plug the cable into the same machine, and they wanted to exchange the data, that part. KIX used to be in Seoul. I'm not so sure now. KIX is now in 용인에 있나? I don't know. I was there for about a week in that room for doing something long time ago. If you stay in those rooms for a week, 1 week, you go crazy. You hear the noises and it's not a good environment. Anyway, so this is typical maps like. Next week I will find some web pages about internet exchange point. So I give you some hints about it. This is what Sprint maps look like in the US. So those green things are cable connections between the cities. Discussing in terms of lots of money. Instead of seeing this, let me show you this website. 뭐야? Level 3 communication is also one of the tier 1 provider, big internet provider. If you go into their maps of a level 3 connection, cable connection website, they show you this. This is how some of the underwater cables, the fiber cables are connected over the world. And I think some of them is theirs, some of them are they're borrowing from some other providers. So this is map of the network. I don't know too much details about level 3. Only thing that I know is level 3 is part of the military company. So, 어디더라? The company who make the Patriot missile systems, etc. 뭐야? Do you know the name? I forgot the name of it. Raytheon. I think Raytheon is the company, the missiles and military. So they also is a part of this company that running a global network in this way. 그러니까 if they don't like us, they can cut the cable anytime they want. So it's the biggest power they can have. They also provide the limited information about the link. This is the PCCW, which is based in Hong Kong. Hong Kong still probably the largest cable connection point in Asia. This is their cable status, where they maintained. Yeah. It's much bigger than I thought, though. Yeah, I thought their cable was dedicated within regions of Taiwan and Hong Kong. It's much bigger. Nice. And these cables are really expensive. Really expensive, though. You can see that there are not too many cables to go directly to the US from Korea. This is Korea, Busan area. I think there is a link to Seoul, but PCCW doesn't have an access to that. When the Japanese earthquake happened, I was there. The cable was cut in this way because it was shifted, right? Lots of underwater cable was hit by the mudslide. And I don't think they still fixed it yet. Yeah. I mean, they told me, I'm not so sure 100%, I just heard. It's much cheaper to install a new cable than fixing one. Yeah. It's very interesting.
Oh, I have a question. Are these cables like deep underwater?
Yeah, some of them are underwater cable. Yeah, it's very expensive, and there's only a few ships that go around and fix these cables. It takes lots of time to fix those. I don't think a single company owns this cable. It's more like a consortium, and then they invest money together. Yeah. And what else? Oh, there's lots of different story about these cables I can discuss. Because luckily I was in Japan when that happens. We were monitoring this type of situation. It was so much fun. It was so much fun, though. What else was missing? Yeah, also Taiwan often having an earthquake, right? So their cable situation was really bad too. Lots of underwater cable was shutting down too. So if you're interested, you can take a look at these maps. But this is more of physical maps, the cable actual physical connection maps. 그러니까 외국에서 보면 아직 한국 네트워크는 되게 조그마죠. So if you look at from outside, Korean network is really small. We don't own too much underwater cable. We cannot. We're so poor that we cannot own any underwater cables and etc. 그래서 그런 게 대단하잖아요. The owner of the SoftBank announced that he will set up a dedicated link from Fukuoka to Busan. He will spend his own money to install a cable to build the data center in Korea, because he's afraid he need to have extra backup centers for his company. But Japan is suffering from too much earthquake, so he decided to put one in Busan. So he said, "I will put a cable for you." And he can do whatever he wants. Anyway, this is the U.S. situation. I'm not 100% sure about the U.S. Cable part, but in case of Japan and Korea, these cables usually along with the highways. Just because when they do the construction, it's probably cheaper. They don't have any other extra cost. And in case of Japan, when the Japanese earthquake hit, all the highway went haywire, so all the cable was also cut too. I'm not 100% sure about the United States, but it probably similar to where the road goes, they install the cable on the sideways.